So how do you perceive physics, the subject physics? Ohima, how do you perceive the subject physics? Please give me a minute. I'm coming, eh? Sorry, just a minute. I'll be with you. All right, so I'm back. Sorry for the interruption. So how do you perceive the subject physics? Is physics challenging? Please feel free and express your views. Ohima, go ahead. I'm listening.
Physics is not challenging when you understand it very well.
Okay, so it hasn't been so challenging to you, right?
Yes.
Anna, let me also hear from you. Hey, Anna will not talk. Amayo Kek. The rest wouldn't want to talk. Oh, it's a bit disturbing. All right. That's okay. Let's Nana Efron, do you want to share something with us? Okay. All right. Then what I'll do today is that we'll begin with fundamental concepts in atomic and nuclear. Because you see, as you said, that's the only area that wasn't covered last semester. So I'll start with that. And then perhaps take you through the other areas which were given to Gehe girls. So I'm Mr. your physics facilitator. I've on my video so you can see me. Okay. So this is Mr. Adria. I'm going to take you through physics. Is that okay? And I'm hoping you all cooperate, with me so that physics will be lovely and enjoyable to us all. Okay. All right. Now let's look at some rules or do's and don'ts. As I did indicated earlier, whenever you join an online class, please you mute yourself and then off your video in order to prevent interference or distraction. Because if your audio is on, yes, it will interfere with the teachers or the facilitators, whatever he's delivering. Then if your video is on, it can also create that attention on you. Instead of your colleagues paying attention, they will be looking at you, okay? Now, so if you want to contribute to the discussion, you can do that by unmuting yourself. So at the moment, I'm muting myself. You just tap on the microphone. So when you tap on the microphone, that red cross, okay, will be seen on the microphone. If you want to off the video, you also tap on the video, it will go off. If you tap on it again, it will come on. Now you can contribute to the discussion by sending text message. So if you go to the chat, Okay, if you go to the chat and then you tap on it, it will give you that surface where you can send your message. So I'm demonstrating something. So good evening. I'm just demonstrating. So I'm sending good evening to the group. Then there is that envelope thing. Just tap on it and it will come to the group. Is that okay? Then if you want to contribute for that orderliness, you must actually raise up your hand. So go to React. When you tap on the React, you have various icons, send with effect. If you want to raise up your hand, there is raise hand. So you tap on it, your hand will show. Then you'll be called. Okay. So these are few rules of the game. Let's, practice it for a better or a fruitful engagement, right? What I'll also be doing is that I'll be sending, if you want to drop your hand, tap on it again and it will go off. I'll be recording our meetings. Yes. Mr. Johnson, your hand is up.
Yes.
Yes. It's good you are here. So just as Mr. Yosin demonstrated, please, that's how we should all, do. So I'll be sending you recordings of our meetings so that in case you miss something, you can get. Or you demonstrated. Kek, do you have anything to ask? Or you demonstrated? All right. So let's.
Sorry for the interruption.
Okay, so let's go back to the whiteboard and then. Okay, so let's review whatever you were taking through under behavior of light through different media. We are reviewing today, but we'll start with fundamental concepts in atomic physics, atomic and nuclear. I hope you can all see the screen. Please, Edmond, mute yourself. Okay, let me even control. I can also control it. So, fundamental behavior of light in different material. Class, what is light?
It's being recorded.
Class, what is light? Can any one of you share with us what we actually mean by light? What is light? Please, your views are warmly welcome. So feel free to express what you know about the question. What is light? What is light? Ohima, are you here? Ohima? All right. Okay, I think it will be it would only be coming from the teacher since a lot of you don't want to. Kek, I'm listening. We are listening, Kek. All right. So, Kek, it's unfortunate your network isn't okay. The feedback I'm getting from here is bad. Edmond, What is light?
You said light is the electromagnetic radiation that helps vision to be possible.
Thank you. Thank you.
You're welcome.
All right. So light is that part of electromagnetic radiation that enables us to see, or that enables viewing. Okay. So in the definition, there are key areas or concepts we must understand and then apply. So that part of electromagnetic radiation or you can even use electromagnetic radiation or waves that helps us to see. Now, let's understand what we mean by electromagnetic radiation or waves. Can somebody share with us what we mean by electromagnetic radiation or wave? Feel free to contribute, please. Feel free. Anybody? Kirk, can you, throw more light on what you said, the meaning of electromagnetic radiation? All right, so we have what we call electromagnetic spectrum. Electromagnetic spectrum are grouping of waves with that common features. Okay, so that the grouping of waves with that notable common features, which I'll discuss with you, is what we are referring to as the electromagnetic spectrum. Under the electromagnetic spectrum, it's like similar to having a bigger room. Within the room, we have grouping of waves based on their frequencies and wavelength. So the whole room or house is what we are referring to as the electromagnetic spectrum. Okay, the occupants of the room, we have waves, various waves, such as gamma ray, X-ray, ultraviolet radiation. We have visible light. What could you, Kirk actually said, visible light. We have infrared radiation. We have microwave. We have radio waves. We have TV signals. And all these are individual rays or waves which constitute what we call as electromagnetic waves or radiations. So light is that part. This is it. There's a light we are talking about. That part of the electromagnetic radiation or waves that enable us to see. Is that okay? All right. Now, let's look at the importance of visible light. How important is light to us? Importance of light. Yes, in fact, as for this, I think each one of us must be able to say something. Importance of light. Who will break the ice for us? Anyone? Importance of light. Hey, Ohima, you are missing. You are not talking again. You are the class prefect. So, can you hear me? Please, whenever you are ready. Okay. Edmond is ready. Edmond, go ahead.
Okay, so light is essential for photosynthesis.
Thank you. So, living organisms, of which plants are parts, use visible light for photosynthesis. So, one, for photosynthesis. Photosynthesis. Two, yes, importance of light. Ohima.
Light helps us to see.
So, enables vision. Thank you, Ohima. Enables vision. More views. Ohima, your hand is up again. If you have more, just share with us. Yes, Infinix. Infinix, go ahead. What's your name? Oh, Infinix, I'm listening. Oh, it's unfortunate. He's not talking. Oh, Infinix, your hand is up. Please go ahead. Okay, 7 Yabwa. 7, go ahead. Okay, Edmond.
It
Okay.
provides it provides our body with vitamin D.
Thank you. Thank you. And this has to do with a certain time within the day. So as a source of vitamin D. Okay, Edmond.
Okay, so with light, it also helps control weather patterns because light produces heat, and then with heat, in respect to the water cycle, the heat helps to melt the condensed clouds to produce rain in the form of precipitation.
So hydrological cycle. Thank you.
Yes.
Okay, so it controls the hydrological cycle. Infinix, your hand is up again.
Yeah, light helps in power generation.
Okay, can you explain? It's a very good point you are raising. Can you explain a little bit?
Okay, so as in solar energy.
Thank you. Thank you. So light enables us in power generation, as in solar energy. Thank you. Do we have more? So it's also, as Edmond said, it's also a source of heat energy on Earth. Don't forget, the source of energy on Earth is the sun. The sun provides light as well as heat. Is that okay? Good. Okay, go ahead. All right. All right. Thank you. Thank you for the contribution. Now, let's look at the behavior of light when it interferes with different media. Okay. What are the properties of light? let's discuss properties of light. Yes, properties of light. Edmond.
I would say one property of light is that light travels in a straight direction.
Okay, so of light. Light travels in a straight line. One, thank you. Yes, go ahead. If your hand is up, please go ahead.
Light can be reflected.
Okay, in a straight line. Light can be reflected. It can go through reflection. It can also go through refraction. Refraction.
Reflect.
I've talked about reflection, refraction. Lamb, okay. Please, the class is for all of us. Let's just feel free to, contribute, okay? Do not feel shy of whatever. We are learning. We can be correct, you can be wrong. And so let's feel free to. Light can be reflected, it can be refracted.
Diffracted.
Kirk, your line is breaking.
Diffracted.
Diffracted. Evelyn, Evelyn, go ahead. Oh, okay. It can be diffracted. It can be interfered. And then can be polarized. It can go through polarization. Okay. All right. Now look at these properties. We need to understand what we mean by reflection and then refraction. So this is a concept that has been treated by you. So let's just touch on a few of them. Reflection. What is reflection of light? What is reflection of light? I think this is another area which was treated in JHS. What do we mean by reflection of light? Sir John, Braco, Stephanie, and co. Please. Oh, Edmond seems to be the only one, who wants to share something. Okay, I have Nana Heffron. Heffron, go ahead.
Reflection of light is the bouncing back of light upon hitting a surface.
So the bouncing back of light upon hitting a surface or upon incidenting a surface. Good. Good. What are some of the conditions that must prevail for light to be reflected? Conditions necessary for reflection of light. Yes, Samsung. Samsung, go ahead. Oh, conditions that must be, or factors which depend or which determine the extent to which reflection would occur. Yes, Nanayao. Edmond.
Okay, sir, please, light must travel from one medium to another.
Can you explain?
Right. With a reflection of light, light must travel from a less denser medium to a more denser medium, like from air to glass.
And when that happens,
There's reflection of light.
Okay, so
So when
Edmond,
that happens, say,
I'm listening.
you say when that happens, there'll be reflection of light because the light will bounce back
I have a
since it has
follow-up
hit.
question. Edmond, you are saying that for light to be reflected, it must travel from a less dense medium to a more dense medium, right? I
Yes,
agree with
please.
you.
Yes.
The light from the sun travels that distance through air, even from space, through the atmosphere, and then incident on the ground. Edmond, why
Yes.
don't we, how come that we don't experience reflection when the light interferes with the ground?
Because the ground is not a, a, a shiny, polished surface.
So then what it means is that this is not the different media does not determine so much the extent to which the light will be reflected.
Yes,
Do
please.
you understand?
Yes, please.
Okay. We have other hands. Ohima. Oh, Nana Hefron's hand was up before Ohima. So Nana Hefron, let's hear from you.
The presence of a surface.
The presence of a surface. Hefron, can you explain a bit?
So in order for there to be reflection, there must be a surface in which the light will bounce back from.
So just as Edmond said, there must be two different media. Okay, let's hear from Ohima. Ohima, let's also hear from you.
You need a source of light and a surface that can bounce back the light. For example, mirror.
Okay, so one, the nature of the material. Nature of the material. Is the material solid? Is it liquid or gas? The kind of material involved will determine the extent to which the light will be reflected. And then two,
Okay.
the nature. Ohima, your hand is still up. Ohima, go ahead.
Oh.
Oh, Nana Hefron instead. Okay, Hefron.
Okay.
The angle of incidence.
Yes, we'll talk about that. Please mute yourself if you are not talking, okay? Techno Spark, Techno 5P, please do that for me. Nana, I'll talk about that, okay? Then there's the nature of the surface, nature of the material, and then how smooth or rough, or let's put it this way, the smoothness level. Level of the surface or of the smoothness level of the surface. Now, you see, you know, reflection also occurs on the surface of the earth or on the ground. Reflection would occur on all surfaces, whether smooth or rough. But the point is that you appreciate or see reflection better if the surface of incidence is highly smooth. That is why we could appreciate reflection on the surface of a mirror and on the surface of calm water, on the surface of well-polished surface floors. Okay, so the extent to which the surface has been smoothened or determines the nature of the extent of reflection. So factors or conditions necessary for reflection is that the nature of the surface count. Don't forget, if the material is solid, reflection can be better than if the material is liquid or gaseous. And then if the surface of interaction is well smoothened, reflection will be better. Is that clear? So I'm sure you treated types of reflection. Please, did you do that? Did you discuss types of reflection? Class, did you treat types of reflection? You don't remember? Okay. So under types of reflection, we have what we call regular. I'm coming. Please, I ask you to mute. Okay, let me mute all. You unmute whenever you want to contribute, okay? So under types of reflection, we have regular or specular reflection. Then we have irregular or diffused reflection. So these are the two main types of reflection. What is regular reflection? Regular reflection occurs on the surface of well-smoothened surfaces, such as, so regular reflection occurs on the surface of very smooth surfaces. Okay, please, because I'm recording, I wouldn't be writing so much. So, reflection occurs on smooth surfaces, such as mirrors, such as surface of calmed waters, then well polished surfaces. Well polished surfaces. Now, if this is the surface of interaction, example, mirror, in regular reflection, so this is the polished, the coated part of the mirror. The uncoated part represents the surface of incidence, where light incident. So in regular reflection, what happens is that light incident on the surface in that regularly or orderly manner. So this is one ray, another ray, at least 3 rays of light or beam would do. Then another rays must always be indicated by straight lines with arrows. So this is an indication that these are parallel incident rays. And So the incident rays or beam of light is orderly. Then after its interaction with the surface, the reflected beam is also orderly. The reflected beam of light this is also orderly in that orderly manner. So these are also, so in regular reflection, light incident on the surface in that orderly or regularly manner, and the reflected beam is also orderly. This is what we mean by regular or specular reflection. This is a mirror. Okay. Now, whenever regular reflection occurs, there is formation of virtual image. Regular reflection always creates a virtual image. So that is why whenever you look at yourself in the mirror, you see an image of you. Whenever you look at yourself, okay, on a very well polished floor, you see the image of you, okay, on the ground. If you look at yourself on a well polished wall, there is an image. So regular reflection brings about formation of images, and the image most often is virtual. Class, are you there? Are we there? Let's then look at irregular reflection. Irregular or diffused reflection. In diffuse reflection, let's just give a quick diagram. I want to quickly clean this part. Instead of flipping to the next page, I just want to use the same. So in irregular reflection occurs on the surface of, on rough surfaces, such as the ground or walls, rough surfaces. So this is a rough surface. It can be the ground, wall, okay, disturbed or not so calm water. The surface must be rough. And what happens is that light incidents on the surface in that orderly or regularly manner. So we have regular incident beam. But what happens is that the reflection is disorderly. So light incidents on the surface in that regularly or orderly manner, but the reflected ray or the reflected beam is irregular. So this is reflected in this direction, the other ray is also reflected in that direction. We have this. So the reflected rays are scattered. They are scattered. Unlike the regular one where we have regular incident and regular reflected ray. Okay, so this is what we mean by irregular reflection. Ohima, Edmond, and Kirk, and the rest of you, are you there? Let me hear from you.
Yes, please.
All right, I hope you are following.
Yes, please.
Please, if you have any question, quickly ask so we can continue. Is there any question? Now, if you do not have a question to ask, my question to the house is that, is irregular reflection important? Is it important? Ohima, Edmond, Kirk. Let me mention names. Euradua, Rabiatu, Samsung, Stephanie, Yaya, and the rest of you. Is irregular reflection important? Edmond, is it important?
Say in a way.
Which way, Edmond? Which way? How do you
Okay,
say?
also enables it also enables us to see.
Okay. Nana Hebron.
So I believe that it's important because it allows us to know how light reacts upon hitting a surface that is not smooth.
Okay. More views. The importance of regular is that, yes, all that you said is also part of, can be attributed to regular. But the key importance, aside what we said, what you shared with me, is that, you see, regular reflection or irregular reflection also ensures evenly distribution of light from the sun. Imagine the surface of the earth is smooth like what happens on the surface of the mirror, very smooth. It means that light would incident in that orderly manner and then will be reflected in that orderly manner as well. So one, if you don't happen to be within the angle of reflection, receiving light will be a problem. When you also receive it, the intensity of the sun received would also be a problem to you because it is only concentrated at a particular area. Please, are you following? Are you following?
Yes, sir.
Light, as we receive on the surface of the earth, is evenly distributed because of the irregular nature of the surface, things on the surface of the earth. On the surface of the earth, we have all manner of items with different cross-sectional area and then texture. We have water, we have stones, we have trees, we have named them. Wisteria is there, Ohima is there, cloth. So because of the varied nature of items on earth, we have varied area and then smoothness level. And all these enables equitable distribution of the light from the sun. And it also equitably distributes heat energy from the sun. So even if you find yourself under a canopy of tree, light will still reach you. Even if somebody is within the depth of water, there is some amount of light reaching the person, and then heat as well. So the irregular or diffused reflection of light. One ensures evenly distribution of light from the sun. It equally ensures evenly distribution of heat from the sun. Okay, so it is equally important. Please, is there any question? All right, let's look at laws of reflection. Laws of reflection. Yes. What are the laws of reflection? What are the laws of reflection? Anybody? Emmanuel, you are here. Can you give us one of the laws, fundamental laws of reflection, Emmanuel? Emmanuel, my focus is on you. Okay. Okay. Please feel free to express what you think. Yes, Edmond.
So, okay, so with the laws of reflection, is it that the incident ray, the reflected ray, and then the normal all meet at a point?
All right, so he's saying that incident ray, reflected ray, and then the normal at the point of incident, or the normal all lie within the same plane. So graphically, as a reflection occurs on all surfaces, whether rough, smooth, curved, or whatever. So this is smooth surface, and whenever we talk about smooth surface, we are always looking at the mirror, but it can be well-polished floor as well. So we must draw a normal. A normal is an imaginary line which is always perpendicular to the surface. So let's assume this is that line which is perpendicular to the surface. So the normal. How do we, please, how do we measure angle of incidence? How do we measure angle of incidence, class? How would you measure angle of incidence? Lamb. Okay, Edmond seems to be the only one. Class, I'm encouraging all of us to be contributing, okay? And don't be worried about whatever you say. We are learning. It can be correct, it can be wrong. It's whether it is wrong is also part of the learning. Okay, so please do not hesitate in expressing your views. I beg you. Ohima, I put it to you. And that is, how do we measure angle of incidence? Ohima. Ohima, I put it to you. So, okay, Edmond, how do we measure angle of incidence?
Yes, yes. To measure the angle of incident, you have to calculate the angle between the incident ray and then the normal.
All right, thank you. So, class, you see, to measure angle of incidence, you first must use your protractor to measure an angle of 90, a line which will be at 90 degrees to the surface, the mirror, and that is the normal. So you must first get this, and the normal must always be perpendicular. That is why I said you have to use your protractor to measure a line which will be at an angle of 90 to this. Then, after determining your normal, you measure that given angle from the normal. So angle of incidence is that angle from the normal to the incident ray. So if this is the normal, that angle from the normal to the incident ray, then I can confidently say that this line is the incident ray. And all rays must be indicated with arrows. This angle is equal to angle of incidence I. Then the two main laws says that angle of incidence must be equal to angle of reflection. So if this angle is 30 degrees or 60, whatever, then we must equally measure the same angle from the normal. The same angle. Okay. So the same angle must be measured from the normal, and we draw the reflected ray. All rays, whether incident or reflected, must be denoted with arrows. Okay, so we have incident ray, the reflected ray, the normal at the point of incidence all lie in the same plane as the first law. And then the second law says that angle of incidence must be equal to the angle of reflection. Please note that as a reflection can occur on whether smooth or curvy. So if I draw a perpendicular line to this, that is the normal. An angle from the normal gives us the incident ray. And to actually show that this is an incident, the ray must be coming from a source and being directed to the material, okay? And to indicate that this is reflected, a ray from the material or the object must be leaving it. So this is I, this is R, and this is the normal. So whether the surface is smooth, the surface is rough, please, the value is still the same. Now, class, what name do we give to this angle? What name do we give to the angle between the mirror or the surface and the incident ray? The angle between the surface and the incident ray. What name do we give to it? Anybody? If you have no idea, okay, this is known as the glancing angle. Glancing angle, X. So where I is the angle of incidence, R is the angle of reflection, and X, I am I am choosing to represent that by X, okay? It's known as the Granson angle. Now note that X plus I must be equal to, yes, can somebody help? The Granson angle plus the angle of incidence must be equal to what? And an iPhone.
90 degrees.
90 degree. And because I is equal to R, what do you think will be the value of this angle? What will be the value of this angle too? If I is equal to R, what do you think will be the value of this angle? The angle from the medium to the reflected ray. What will be this angle too? Can anybody help? Evelyn. Evelyn. Oh. Okay, Edmond.
Okay, so it will also be equal to the Granson angle.
So that will also be X. Thank you. So please know this. We'll be applying this in solving problem. Now let's try and then determine the angle of deviation. So we've seen what angle of incidence is, angle of reflection, and then the Granson angle. What about angle of deviation? What do we mean by angle of deviation? This is a smooth surface mirror. Then my normal is here. This is an incident ray. Ideally, this is the direction of the incident ray. It's supposed to travel straight. Let me change the color so as to create nice outlook. So this is supposed to be the original path. But this wasn't possible because of the light interaction with the surface. And so instead of moving straight, the moment the ray hits the surface, its direction changed. The direction changed to this part instead. So if I want to measure how much the part of the ray has been deviated, the original supposed direction must be this, but it's been deviated to this side. So the whole of this becomes the angle of deviation. Let's represent that by alpha. So where alpha is equal to the angle of deviation. Class, if I want to determine the value of this alpha, how do I calculate it? If I want to calculate or determine alpha, how do I do that? Can somebody help? I want to determine the value of alpha. How do I do it? Yes, don't lose sight of the fact that this is angle of incidence. This is angle of reflection. So if I want to determine alpha, what is the angle of deviation? How would I do that? Engage your brains and share it with me. So just think through and then share it with me afterwards, okay? Just share with me whatever you may possibly have. Okay, Edmond is ready. Edmond.
Okay, sir, please, to calculate the angle of deviation, you have to first calculate the angle of reflection and then the glancing angle, and then you add it to the angle of deviation or subtract.
No, so Edmond, my question is that based on the information you have, what can we have as the angle of deviation alpha?
So please, no idea.
Oh, just think through it. Okay.
Okay.
Please think through it. So whatever you see, you share with us.
Okay.
Let's think through it. If that is what we have. If we have angle of incidence, don't forget that angle of incidence I is equal to the angle of reflection. Meaning, if this is 30, this will also be 30. So in that case, what will be the angle of? Okay, let me come in. Let me come in. Now, what is this total angle? What is this? What is this total angle? Nana Heffron.
90 degrees.
I disagree with you, Nana Heffron. Look at this. I mean this total angle. Nana Heffron, come again. Edmond, please. Good. Edmond, mute yourself, okay? So
okay.
This total angle is 180. Ahim, are you there? Anna, are you there? Now, if this is I, because angle of incidence is equal to angle of reflection, if angle of incidence is I, we can also say that then angle of reflection would also be I, true or false? Can we say that? Ladies and gentlemen, can we say that?
Yes.
Okay. So, if this is 180, this is I, this is also I. Help me get an expression for alpha, which is this whole angle. Okay, alpha will be, if I subtract the sum of this angle, the angle between the incident ray and then the reflected ray, what will be this sum? What will be the sum of the angle between the incident and the reflected ray? When you add them, what will you have? That's 2i, isn't it? If this is 30, this will also be 30. 30 plus 30 is 60. So if we have I, then this is I. So the sum is equal to 2i. So if I subtract 2i from 180, I can get this. This is 2i. Okay, and I need this alpha, which is this angle. If the whole angle is 180, 180 minus 2i would give me alpha. So under mirrors or under reflection, angle of deviation is equal to 180 minus 2i or 180 minus 2r. Because I and r are equal, it can be I or it can be r. So please do not forget this. This is angle of deviation in mirrors. Please, are we okay? Class, are we okay?
Yes, sir.
The ladies in the building, are you okay? The ladies, let me hear from you. Okay, so class, this is your work. We are given angle of incidence to be 35 degree. 1. Angle of incidence is 35 degree. Your first question is that determine the angle of reflection. Determine the angle of reflection. II, the glancing angle. So you have to calculate the following. Angle of reflection. The glancing angle. Then angle of deviation. Please start work. Whoever scores everything wins a traveling visa to Dubai after COVID. So start work.
Master, there.
Start work.
Calculate what?
Calculate the angle of reflection, the glancing angle, and angle of deviation.
Sir, please.
Hello, I'm listening.
Sir, please, the angle of refraction is 35.
Angle of
Then-
reflection. Don't please write it, okay, so that others can also engage. Okay, just write it in your book. All right, Edmond, do not share with me. We'll discuss it. I want everybody to be involved. Oh, you have a question to ask.
Sir.
Edmond.
Yes, sir. Oh, please, there's no question.
Okay, so just put it down.
Okay.
Sir.
Hello.
Sir, please, should I say?
No, write it. We'll discuss it. So as we discuss, you will be marking yourselves, right?
Okay.
So that others can still be doing it.
Okay, sir.
Are we all through? All right, so I'm sure by now everybody is done. Let me clean this side of the board. All right, so angle of reflection, angle of incidence by the second law of reflection, angle of incidence is equal to angle of reflection. So if angle of incidence is 35, then the angle of reflection must also be 35 degrees. Then II. Please mark, start marking II. If I look at this whole angle, the angle of incidence and the glancing angle, or the angle of reflection and the glancing angle, they all sum up to be 90. So X, which is the glancing angle, plus I must be equal to 90. Therefore, X would be equal to 90 minus I. So 90 minus 35, which is equal to 55. So the glancing angle is 55 degrees. Now I. For mirrors, for plane mirrors, the angle of deviation alpha is equal to 180 degrees minus 2 times I, or 180 degrees minus 2 times R. Whichever way you look at it, the value is still the same. Therefore, angle of deviation alpha is equal to 180 minus 2 times 35. And this is 180 minus 70, which is 110. Please show by hands those of you who scored everything. If you scored everything, raise up your hand. Anahe Front got everything. Kumsin, Asabre, okay, Edmond, said Braco. In fact, we must score. We must score. Okay. All right. All right. Thank you so much. Thank you so much. Okay. Now, do you know we have different types of mirrors? Types of mirrors. We have plane mirror and spherical or curved mirrors. Please, did you treat types of mirrors in school? Did you treat? No. You didn't?
No, sir.
Okay. What I'll do is that I'll look at the depth of whatever you need to learn under this concept. Okay, and then I'm sure spherical mirror must be treated. Now, today is just first meeting, and so Kumsen, please mute yourself. Class, whenever you visit the barbering salon, and then you see 2 mirrors, one in front of you, another one behind you, and you look at yourself within the mirror. This is you being barbed. Your hair is being trimmed. If you have 2 mirrors, one in front of you, or 2 parallel mirrors, and the other one behind you, when you look at yourself in such mirrors, how many images of you can you usually see? If you have two mirrors parallel to one another and an object is in between, how many images of you do you see in such mirrors? We all visit the barbering salon. So let me hear from you. If you visit and you have two mirrors, one in front of you, another behind you, and you look through it, how many images of you do you often see? Yes, Evelyn. Evelyn, I'm listening. Hello, Evelyn. Okay, Infinite. Infinite.
Sir, please,
Come again.
two images.
Two images. Are you sure?
Yes, sir.
Just pick two mirrors.
Yes, sir.
Let your brother hold one, your sister hold another. You must be in the middle and then look at yourself in the mirror if you see two. Okay, Edmond, let's hear from you.
Okay, so with that, you see more than two.
How many?
Quite a number. So I actually can't tell the number.
Okay, Hefron, what is your observation to this regard?
Sir, please, you see a lot of images.
You see a lot, uncountable number. You see uncountable number. Now, number of, okay, I have a message. Let me. All right. You see uncountable number of images. Number of images formed when two mirrors are inclined to one another is given by this equation. 360 divided by the angle between the two mirrors, theta, minus 1. So n is equal to 360 over theta minus 1, where n is equal to number of images. Theta is equal to the angle of inclination between the two mirrors. Two mirrors. Please, the formula only applies to two mirrors. If you have three mirrors, then you must look for your own formula. So for two mirrors inclined at each other, n is equal to 360 over theta minus 1. Now, if theta is equal to 90, how many images will be formed? If the angle of inclination between the two mirrors is 90, how many images will be formed? Anybody? Nana Hefron.
4 images.
Are you sure? Look at it well.
And all the knowledge needed to fly the vehicle will be transferred
3.
to his mind. Young-Soo enthusiastically shares this
So
discovery.
here, this is what we mean. So we have two mirrors. And the angle between them is 90. So this is mirror 1. This is mirror 2. 7 year what? Leave my board alone. This is mirror 2. So when an object is placed here. You see 3 images. So n will be equal to 360 over 90 minus 1. And 360 over 90 is 4. So 4 minus 1, which is equal to 3. Ohima, are you there? Oh, she's gone. Call Kumsen. Call. When theta is 30, when the angle between the two mirrors is 30 degrees, how many images will be formed?
Sir, please. 11.
Okay, let's see if that is correct. So n in this case will be 360 divided by 30 minus 1. And what is 36 divided by 3 is 12. So 12 minus 1, 11. Thank you, Kumsen.
You sir.
Now, when two mirrors are parallel to one another, what is the angle between them? As in this scenario, the scenario we discussed, when two mirrors are parallel to one another, what is the angle between them? Anybody? When two lines are said to be parallel to one another, what is the angle between them? The angle between two parallel lines. Edmond, do you have any idea? What is the
Sir, please,
angle?
I'm thinking about it.
Okay, so Ohima, are you also thinking about it? Hey, Ohima, you were vocal from the beginning. So, Evelyn, what is the angle between two parallel lines? Oh, Evelyn's line. Infinix.
Sir, sir, please 0 degrees.
0. Thank you. Thank you. Thank you so much. So, when two, you see, so look at two mirrors parallel to one another. It means theta, the angle between them is 0 degree. Now, let's use our equation to determine the number of n would be equal to 360 degree divided by 0. 0 minus 1. Class, what is 0 minus 360 divided by 0? What is 360 divided by 0? Anybody? You can use your calculator. 360 divided by 0. Oh, where are they? Edmond.
Sir, please, it can't be divided by 0.
So what did your calculator give you?
Sir, give me error.
Error. Okay. So
Yes.
what does it mean? Okay, so in mass, any number divided by 0 is said to be undefined. Any number divided by 0 is undefined. Okay. Undefined. Now, what it means is that undefined does not mean a 0. But look, if I have the number 1, and I'm dividing by large values gradually, and then divided in such a way that the denominator approaches 0. So 1 divided by 10, for instance, this is 0.1. 1 divided by 8. Yes, what is 1 divided by 8? Quickly do that for me. Class, what is 1 divided by 8?
So please, I got 0.125.
0.125.
125.
1 divided by 6.
0.1666. It's reoccurring, so
Okay,
you just
so
round it up to 7.
1667. So 0
Yes, please.
divided by 5. 0.2.
0.2.
00.
Yes.
So class, look at the trend. The denominator is gradually decreasing, and we are decreasing it gradually to 0. So 1 divided by 2 would give us 0.5, isn't
5.
it?
Yes, please.
1 divided by 1
So 1.
is 1. 1 divided by 0.9. This is 1 point what?
1, 1, 1, 1, 1.
1, 1, 1, 1. So
Yes,
1 divided by 0.1111. We are decreasing the denominator gradually. So let me even do that for 1 divided by 0.1. What is 1 divided by 0.1? That is 10, isn't it?
Yes, please.
Good. So 1 divided by, let's write a number which is close to 0, but not exactly 0. 1 divided by 0.00001. 1 divided by 0.0001.
So we'll give you 100,000.
So what it basically means is that if you have a fraction as the denominator x approaches 0, the whole fraction becomes very, very large. And we said that is equal to infinity. So if you have a fraction as the denominator approaches 0, the whole results will be equal to a large value, infinity. So as we approach 0, the answer becomes very, very big. And so that is why when you input 1/0 into your calculator, the result is a very large value which cannot be determined by the calculator. And so it will simply give you error. But it does not mean a 0. It's a very large answer. Okay. And mathematically, we said that any number divided by 0 is undefined. Undefined means that the result is a very large or infinite value. Please, class, is that okay? And this is the reason why if you have two mirrors positioned in this manner, you have uncountable images. This is the reason why when you place two mirrors parallel to one another, the angle between them is 0. And so the results must give you uncountable images. Class, are you okay? Class, are we okay?
Yes, sir.
All right, please, the rest of you must also talk. Let me give you a mathematical joke. A friend was given this question. Now, what is 8? The teacher solved an example on the board. 8 divided by 0. And this is the teacher's answer. 8 divided by 0 is undefined. So the answer is equal to infinity. Then the teacher gave an example. Okay, if 8 divided by 0 is undefined, Kofi, come and give an answer for 7 divided by 0. And class, guess what? This is the answer given by Kofi. This is Kofi's answer. Do you see anything? Can you read meaning into what he had or he wrote? He thought that, oh, if you are given 8 over 0, all that you need to do is to turn the number. So if I'm giving 7 over 0, oh, then I must just turn 7 upside down. If I'm giving 9 over 0, just turn 9 upside down, and that's the answer. So that is just by the way. Class, today being our first meeting, I will end today's lesson here. We are working on a timetable. By Monday, it will come out, and we will know specific days other teachers or we teachers will be engaging you. Okay. So I'll end today's section here. Please, if you have any question, quickly ask. If you have any question, quickly ask. If you don't have any question, we'll end here. But I will urge the class that please, whenever we meet, try as much as possible to express your views. Science is about questioning concepts. So be asking questions, be expressing your views, and the more we do that, the better we become. May the good Lord be with us. Have a very good sleep or a very wonderful sleep today. We'll definitely continue this from Monday. Okay. I'll upload the videos as well. Bye-bye. And
Bye.
Bye.
all right. So I'll share today's video too. Okay.
Okay.
Yes.
All right. Yo, bye-bye.
Bye, sir. Eddie,
Yo.
Lee, how far?